All right, so this is part two of AZ Merit Test Prep, just looking at strategies for how we can utilize the tools that are provided on the computer-based exam. So this sample question says, what is the exact perimeter of a parallelogram with vertices at 3, 2, 4, 4, and 6, 1? So the first thing I would do here is go ahead and graph those ordered pairs. So we have 3, 2, 4, 4, and 6, 1. All right, so looking at that graph, we know that we have one more point that we need to place. Since it is a parallelogram, we know that opposite sides are going to have slopes that are parallel to one another. So this has a slope of 2 because we have a rise of 2, a run of 1. So this line here is also going to have a slope of 2. So if we rise 2, run 1, it's going to put our new point right there, which is at 5, 6, 7, and up 3. So let's test that, make sure I had the right point there, 7, 3. Oops, always need that comma in between. So yep, I put that in the right place. So now the question's asking us to find the exact perimeter. So the word exact means do not use a calculator. Exact means you need to leave your answer as a radical. So here, we're going to need to know the distance between these 2 points. And we know it's going to be double because we have 2 sides of the same length. And we're going to need to know the distance between these 2 points. So let's go ahead and I need my be able to write over here. Okay, and that was question, here we go. So we determined our new coordinate to be at 5, 6, 7, 3. So let's go ahead and write that down here. Okay, so we can either use a distance formula or you can use the Pythagorean theorem to figure out this distance. So we see that those first 2 points have a slope of 2. So we're going to go over 1 up 2. So remember, if you want to find this distance, you could just use the Pythagorean theorem. 2 squared plus 1 squared is equal to 5. Remember, Pythagorean theorem is c squared equals a squared plus b squared. So c is equal to the square root of 5. And we know that we have 2 sides of that length. So that's going to be 2 times the square root of 5. And now let's find the distance between these 2 points. So we know 1, 2, 3. We have a slope of 1/3. So 1/3. So we can find this value, again, using the Pythagorean theorem, 1 squared plus 3 squared, squared. So that gives us the square root of 10. And again, we have 2 sides of that length, so 2 squared of 10. So our answer is 2 square root of 10 plus 2 square root of 5. And that is the way you will need to put that answer into this this answer grid. So 2, and we need our square root of button, 2 square root of 10 plus, let's go back 1. See, there's the danger there. 2 square root of 10, and then plus 2 square root of 5. And that's how you would have to put that answer in, because again, when it says exact, you have to leave it in radical form. All right, so this question is testing your knowledge of cylinders. So this is a right circular cylinder, and this is an oblique cylinder. If they have the same height and the same radii, the same radius, then they are going to have the same volume. And to kind of help you visualize that, if you think of a stack of coins that's sitting upright, and then you just kind of shift each coin over just a little bit, you end up with this shape. So the volumes would be the same, but the way it's kind of oriented would be slightly different. But again, those radii have to be equal to each other, and the height would have to be equal to each other, and not the slant height, the actual height of the figure. So you can see that the heights are equivalent to one another. They don't tell us anything, though, about the radius. So A doesn't work because the radii have to be equivalent as well. B, the volume is always greater because the slant height is greater than the height of the cylinder X. No. The relationship cannot be determined because the slant height of the cylinder is not given. You don't actually need the slant height to calculate the volume of an oblique. You just need the height and the radius. So the only answer that works is D. The relationship between the volume of the two cylinders cannot be determined because the radii of the two cylinders is not given. Okay, so here it's worth pointing out how to use this add point and connect line tool. That's a little bit tricky. So you can see that this translation means that we are going to subtract 4 from our x values. So we're going to go 4 to the left, and we're going to add 3 to our y coordinates. So here we're going to subtract 3, so 1, 2, 3, and add 4. 1, 2, 3, 4. So that's going to be our new point. So when we add a point, we click add a point. Oops. So click add a point. So from here, we're going to go 1, 2, 3, 4, up, 1, 2, 3. So that puts us right there. So let's double check that. 1, 2, 3, 4, and up. 1, 2, oh, actually, we want to be right there. So we want to delete that point. There we go. So we use the delete button to delete a point. So let's do the same with this one. So we want to go left 4, 1, 2, 3, 4, and up 1, 2, 3. So there's our new point. And then same here. So left 4, 1, 2, 3, 4, and up 1, 2, 3. There we go. Now to connect the lines, we just click on that. So click on each point that you want to connect. Click, click again, and then click,